Morning. You sit in your normal seats. They're just spaced out more. J. P. Morning. No problem. Good job on it. I was supposed to wear purple today. Whoops. Howdy. I moved you to that lime green. Yeah, that one. And then the rest of you should sit in your normal seat. So they're just spaced out weird. Yes, go for it. Okay, so I know the spacing in here has put people really far away from the board. So if you're in the back, you can always join the PD at FCJ PIK, and then you'll have this in your Chromebook right in front of your face. For bell work today, actually, we're not going to do traditional bell work today. We're gonna, I think I'm just gonna lecture over it. Because these are the type of problems that I wanted to get to yesterday that we weren't able to. So I'll give you a minute here just to get ready for, get your notes out. We're gonna finish 5.3, which hopefully shouldn't take too long, and then 5.4 sum and difference formulas. I guess I should put in attendance too real quick. Missing a lot of B group people. I suppose that's not too surprising. Oh, there's a B group person. Hey, Jacob. You sit same spot. So, oh wait, no, you kind of sat in a weird. If you want to sit in front of a bio there, that'd be fine. Yeah, this blue chair right there. No, one back. That's Lucas. No, he's not here, right? Yeah. They did good at big questions last night with the math app and egg. They both went 2-1. That's very cool. Okay, I think we're ready. So if we're going to solve this for x, most of the steps are the same as what we've been doing before. I want to get x by itself. So I'm going to add 2 square roots of 2 over the square root of 3 to both sides. That would give us the cosecant of 2x equals 2 over the square root of 3. And then the next thing I would do is get rid of the cosecant, right? Which I would do by taking the inverse. All right, and then how do I find the cosecant inverse of 2 over the square root of 3? What does cosecant tell us on the unit circle? Wow. What's cosecant tell us on the unit circle? Sine tells us the x value of the unit circle, right? So cosecant tells us 1 over the reciprocal, 1 over x. So really, what did I said x? Who said x? Sorry, y. Sine tells us the y value. So cosecant is 1 over y. Okay, so really, how you could find this on the unit circle is if you flip it, it would be square root of 3 over 2. And so I'm looking for where on my unit circle do we have a y value of square root of 3 over 2? Yeah. Right there. And right there. Okay, so here's the new thing though. What you'll get is that you're not done. So you're going to have 2x equals 60 and 2x equals 120. And so in general, you would write that 2x plus 60, or sorry, erase that. 2x equals 60 plus 360n, and 2x equals 120 plus 360n. And now we divide by 2. So we get x is 30 plus 180n, and x is 60 plus 180n. This step is really the only new thing right here. You need to write the general solution first and then divide by 2. What gets people in trouble is they'll take 2x divided by 60 and get x equals 30, and then to 30 plus 360n. But that's not right. You have to write the general solution first. Yay? And that will also kind of mess you up if you have to find all of the values between 0 and 360, because let's pull up this, Bose. Type this in. Cosecant of 2x minus 2 over the square root of 3. Switch this to degrees. Let's go out to 270. Okay. So if you look, here's your answers 30 and 60, right? But between 0 and 360, there actually be 2 more answers because we're adding 180 at each time, right? So 30 plus 180 is 210, 60 plus 180 is 240. So there's actually 4 answers in your standard interval. Which should make sense because again, since we're doing 2x, right, that would mean the period is half as what it usually is. We're going through the cycle twice as fast. So normally when you would have 2 answers, you'll really have 4. Does that make sense? A little bit? And again, at the end, if it doesn't make sense and you sit here and go, no, Mr. Lake, no, I hate this section. You can get the answers by just graphing really fast. All right, let me do one more and then I'm gonna have you try. Does anyone need more time to write? Okay. Oh, after we get done with 5.3, we're going to use sum and difference formulas today. That's what 5.4 is about. We'll not finish 5.4 today. We'll just start it. So we'll evaluate, verify, and solve, but with sum and difference formulas. Okay. So if I wanted to solve this for t, first thing I would do, add 1 to both sides. 2 cosine of 3t equals 1. Divide by 2. Cosine inverse. All right, and remember cosine tells you the x value on the unit circle. So let's go ahead and do this one in radians. Where is x equal to a half on the unit circle? Let's see, right there. And right there. See, I was going to say it's not going to be as hard to memorize this as you think because you're going to use it so often. Right? And we're just halfway through the semester. By the end of the semester, you'd be like, oh, it's actually not as bad to memorize this as I thought. But pi over 3 and 5 pi over 3. Oh. And again, we're going to do the plus 2n now, or it's plus 2 pi n. N is an integer. And so again, you have to write the general solution first. Even if you're only finding the answers between 0 and 2 pi, you have to write the general solution first. Because you're going to use that to ultimately find your answers between 0 and 2 pi. And now that you have the solution written, now we divide by 3. So that gets us t is pi over 9 plus 2 pi over 3n. And t is 5 pi over 9 plus 2 pi over 3n. So again, I don't think this part of 5.3 is terribly difficult. You just have to remember that at the end, like one more step. Which again is tacking on because you already had to learn all the way how to do it. So I could understand how that could be challenging, but if you're okay with what we did before, we're just adding 1, I guess 2 steps. And then as per usual, it's always a great idea when you're doing these problems to check your answer with the calculator. So if we type in, what was it, 2 cosine of 3x minus 1. Let's change this back to radians. Let's go 10. Here, let's go 2 pi. You could see that we have answers at pi over 9, 5 pi over 9. And then if you add a pi, or sorry, if you add 2 pi over 3, 7 pi over 9, ooh, and 11 pi over 9. And those. So again, because we're doing 3t instead of just 1t, normally you would expect to have 2 answers between 0 to 2 pi. But since we're going through the cycle 3 times as fast, you really have 6 answers between 0 and 2 pi. Howdy. Questions on that? Okay. It's your turn then. Look at this one. I'll give you 3 minutes to try it on your own, and then we'll go over it. If at like a minute left, you have nothing on your paper, don't forget you can't get these answers just by graphing. Might be a little bit more work to get it by graphing, but you can get it by graphing. Oh, I should have asked him while he was here. Still wandering around. What do I do with these desks? I thought they were going to take them. But they didn't take them. Oh, he's gone. Okay, I'm gonna walk around. If you need any help, just stop me as I walk by. I'll help you out. Right, yep, tangent. Okay. Okay. Now, tangent. And for them, tangent. So basically, line axis is the same. Well, same amount, but opposite. Okay. Yay. Okay. What's going on? Hey, you're on the same step. Yes, okay, you're both. But yes, that's right. Exactly. And there's one other spot. Yes. Okay, so the key here, tangent is y over x, right? So in order for it to be 1, they have to be the same amount because it's negative, just different sides. 2 spots of that. Oh, actually, yeah, I did specify, so your choice. You can do it. Okay, today. I think that's right. Very good. Okay. So what you want to look for is that y over x. They need to be the same amount. Because it's negative, they need to be different sides. Where's y and x the same number, different sides. Okay, I actually feel pretty good about this. Which is super weird because last time I actually know what the difference is. When I taught this last year, this was picked up by like a quarter of the students or a third. It was a tough area. Maybe that's true right now. And I'm just not seeing it. But I think we're doing actually pretty okay with this. And I think the difference is we had to do it all by hand and then solve at the end for all the answers in between 0 and 2 pi or 0 and 360. Okay. Okay, since we're in person and there is so many of you, I think I would like to go back to my teaching style last year. Well, I'll ask for a volunteer, but if there isn't any, roll the dice and just pick somebody. And then eventually I'm just going to move it to rolling the dice every time and not do volunteers. That way everybody gets a chance. But for today, I'll see if there's a volunteer first. Can someone work me through this problem? It's exciting. You get to be the person. Okay, let's just roll the dice. So roll the dice. 1-1. Ella, you're the closest to 1-1. What is the first thing I need to do? That's right. I get 3 tangent of x over 2 equals -3. How about we'll just snake? We'll have everyone do one step. Is that okay? And just snake around the class. Xander, what do I do next?
Put both sides over 3.
Yeah. That gives us -1. Then what? Tangent inverse. All right, Lucas, this is the part where everyone that I helped got stuck. Did we get stuck here? Yeah, okay, that's all right. So remember, tangent of an angle tells you y over x. So we have to think, how can this be -1? Well, in order for it to be 1, they have to be the same amount, right? And then in order for them to be negative, they would have to be the same amount, but with different signs, one positive, one negative. So where on the unit circle do I have the same y and x values, but they're just opposite signs? Yeah, 135 and 315. See that? And again, you don't really have to make this problem as hard as that, where you're like thinking, oh, it's y over x, and then how can I make that work by quotients? You can Google tangent unit circle images. First one. And then it'll have them all already divided out, so you can just read your answer then. Okay, so what I forgot what we said. 135 and 315. So x over 2 is 135 degrees. X over 2 is 315 degrees. And then Jacob, this is the new thing today. What do I do next?
That's a good question.
Yes, it is. Do I multiply by 2 or do I write the general solution first?
Well, I think you write the general.
They're right. So I have to do the plus 360n first. And then Mariah, last step. Multiply by 2. Oh gosh, that's not how I want to write that. This is how I want to write that. 2 times 2. X is 270 plus 720 n, and x is 630 plus 720 n. And again, the idea, because x is being divided by 2, we're now going half as slow through the cycle. So we're actually only going to get through one period before we get from 0 to 360. All right, if this problem asked us what are the answers between 0 and 360, there's only one. 270. 630, right, is too big. And you can confirm that with your calculator, which is always a great idea. Oh, here. 3 pi over 2. But 3 pi over 2 is the same thing as 270 degrees. Yay? Not too bad? Okay. I think that you all are doing a lot better on this than last year's pre-calculus class. Okay. All right, so there are a few, I guess we'll do this example. It'll take seconds. All right. Every once in a while, you will come to trig equations that are actually beyond our class to solve. This equation, x equals 2 sine of x, in the interval negative pi to pi, is beyond our class to get x by itself. To be honest, it's beyond undergraduate. This would be like a graduate level problem to get x by itself here, because you have a regular x term and a trig function x term, right? So whenever you see a problem that you think, I don't know how to solve that one, that seems like that would be impossible to just get x equals something. And to be honest, there are equations that we use that are very difficult to get in terms of what's called an explicit formula, where x equals whatever or y equals whatever. A good example of that is the Fibonacci numbers, right? Where you go 1, 1, 2, 3, 5, 8, whatever. Am I losing you? Here, let me show. Fibonacci numbers. So you can see it's really easy to generate these. It's pretty fast. Can anyone tell me what the next number is?
21.
How'd you get that?
It's like you add the last two.
Yes. And so if I asked you what's the 10th answer, we could get that pretty quickly by using this. If I asked you what function of 10 gives me that answer, that's really tough. That was actually unsolved for a long time, how to write an explicit formula for Fibonacci, even though it's so easy to figure out what the next digit is in a list, right? You just add 2 each time. But how to write that as a formula was really tough. Well, okay. Okay, so this is the generating formula. F of n is equal to the last 2 numbers, right? But if I want to get this the one without that, it's this. 1 over the square root of 5 times the quantity of 1 plus the square root of 5 over 2 to the nth power minus the quantity of 1 minus the square root of 5 over 2 to the nth power. Yay? Yay. That's a grad school class, undergrad class if you want to, that you take your junior or senior year, is writing explicit formulas for like those kind of seemingly simple problems. So again, this is another example of that. Solving this for x would end up getting like a massively complicated formula. So if you ever have a problem like that, you can always find the answer instead by, it rhymes with graphing. You can do it by graphing. So if I type in negative pi, I almost thought about just not lecturing over this one, but again, how you have to type this in is the left side is one equation, and then the right side is a second equation, and then you see that they intersect there, and you get your 3 answers. Yay. So I think there's one homework question that says approximate the solution of like this really complicated formula. That should be the quickest problem on the homework. Just graph it and then write the answers. Yay?
Yeah.
Yay. Okay. All right. Here's the new thing for today. This is 5.4, using sum and difference formulas. you'll need to copy all of these into your notes. Oh, this cursor has been here this whole time, just hanging out right here. Get out of here, cursor. I don't need you. So again, we're going to use these sum of difference formulas to do the same type of problems we already have. We'll use them to simplify trig functions. We'll use them to verify identities. We'll use them to solve problems. So there's no new type of prompt for today's lesson. It's just we have a new tool in the toolbox to help us do the type of problems we've been doing for the last 2 weeks. And again, this is another set that ideally by the end of this class, you have these memorized. There is a pattern, right, to how they're written. So like the side of u plus v or u minus v is just side, cosine, cosine, side. And then usually put plus or minus, right? The cosine of u plus v and cosine of u minus v is just cosine, cosine, side, side, and then you do minus plus. And then the tangent of u plus v or tangent of u minus v is tangent plus or minus on the top, 1 plus or minus tangent, tangent on the bottom. So there is a pattern to them. They're not completely abstract. Oh, yeah. All right, how are we doing? More time? A little bit? Okay. The big questions debate topic for the rest of you this year is math invented or discovered? That's not quite right. It's resolved. Math is invented, not discovered. So the two sides of the debate, the affirmative argues that it's invented, and the negative argues it's discovered. I hate that topic. I do. I don't like it. But I mean, at least you do get to talk about math, but it's just, I feel like it always comes down to the definition. But the idea, if you have had me before, I've probably shown you the great math mystery when I was gone with the sub. There's a video that played. If you've had me multiple times before, you probably have seen that video a whole bunch where they do a whole bunch of math experiments and then talk it like, does math exist outside of our, intelligence, or is it just what we make it to be? It's a mildly interesting philosophy topic. If any of you want to change courses after quarter 4, midstream right now, join forensics, drop one of your other classes, your counselors will love that. They will definitely approve it. But then you can talk about math and get your speech credit out of the way, or fine arts credit.
Wait, that counts as finance, right?
It can count for actually, I think it could count for 3. It could count for fine arts, your speech credit. I think it could also count as your English elective, maybe. But you have to choose what it is each time you take it. It can only count for one of those things each time. But if you take it again, it could count for the other. Take it again, it could count for the third thing. I don't know if the third thing is English language elective. I have to look that up. I don't remember. Okay. How about now? Good? Okay. Default microphone changed. Yep. Okay. So these are the most typical problems that you'll see that will require you to use the sum and difference formulas. If you want to find the exact value of the cosine of 75 degrees, you can't use your calculator, right? Because you don't want the answer as a decimal. So then you turn to your trusty friend who's never let you down, the unit circle. But alas, 75 degrees is not on the unit circle. Oh no. Panic starts to set in. You get sweaty, right? You call someone, make some bad decisions. But don't fret too much because they will remind you that you could use the sum and difference formula. I could rewrite the cosine of 75 degrees to be the cosine of 45 degrees plus 30 degrees. Right? Everyone agree that's true? 45 plus 30 is 75. And that's an important rewrite because I know what cosine of 30 and cosine of 45 is. I can use my unit circle to find those. So now if I use my sum and difference formula, we would get the cosine of 45 times the cosine of 30 minus the cosine of, or sorry, cosine minus the sine of 45 sine of 30. Remember, cosine of u plus v is just cosine of u, cosine of v, minus sine of u, sine of v. This would be u, and this would be v. And now I can find out what all 4 of these are with my unit circle. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Remember, cosine is the x values on the unit circle for these 2 angles. Sine is the y values. So this would be minus square root of 2 over 2 times a half. And then the rest of this is now just simplifying. Square root of 2 times the square root of 3 is the square root of 6 over 4 minus the square root of 2 over 4. And those have a common denominator. So that's just square root of 6 minus the square root of 2 all over 4. That is the exact value. No decimals, simplified as much as you can. Yay? Yay. What gets people in trouble more is when the problems aren't in degrees, but they're in radians. It's not as easy to see how you could build this angle from any of your special angles. So if that ever is a problem for you, just convert it to degrees, right? Take pi over 12 times it by 180 and divided by pi. And then it's like the problem we just did. Before we do that one, I think I wrote too big. I need to clear this space. Does anyone need more time to write this part? Okay. Then sine of pi over 12 could be rewritten. Again, you could use degrees to do this, but if you did it in radians, that could be rewritten as pi over 3 minus pi over 4. Right? Pi over 3 minus pi over 4. You would need to get a common denominator. So that'd be the same as 4 pi over 12 minus 3 pi over 12, which is 1 pi over 12. So again, when you're looking to find how you could break this apart, notice that it's a really small angle, so you're probably going to have to subtract a bigger angle from a smaller one to get such a small angle here. And then the other thing you want to look at is the denominator and say, what, denominators could give me a 12? And it's either 3 and 4 or 2 and 6, right? Is how you could get a common denominator of 12. All right, and now this is just using the formula, again, where this is u and this is v. So this becomes the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. And now each of those you can find on the unit circle. Remember, sine is y, cosine is x. So if you look those up, you get square root of 3 over 2 times the square root of 2 over 2 minus a half square root of 2 over 2. And again, you just pull those from the unit circle from these 2 points, pi over 3 and pi over 4, your x and your y values. X is cosine, y is sine. And then the rest of this problem is just simplifying. So this becomes the square root of 6 over 4 minus the square root of 2 over 4, which has a common denominator already. So it combines into the square root of 6 minus the square root of 2 over 4. Ba, 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 ba. My jaw is all messed up right now. Yay? Okay. I think we got 5 minutes left, so I think, yeah, we'll just do this guided practice and then we'll finish the rest of this tomorrow. So before I clear this, anyone more time to write? Okay, last problem. Try this one. I'll give you 3 minutes to do it on your own. And then really, once you have your answer, you can start packing up. I'll come around this gray. So, like- I used to be able to do this in 2 minutes. I don't think we're gonna be able to do this in 2 minutes anymore. I have to adjust that time. All right, I'm gonna solve that up here in case you're stuck. You could write this. Is that right? Coast over 3 is a half. That one's a half. Oh. Yay? All right, 5.4, by the way, is not due till Monday. 5.3 part 2 is due tomorrow at midnight. You all can start packing up. We'll finish 5.4 tomorrow. Yay?
The day's taking too long already.
I know.
Uh-huh.
First class, get the hard one out of the way, right?
Well, next I have like AP US history, so like, but then I'll get the hard ones out.
There you go. It's better to get them out of the way in the morning.